Assalamu alaikum. I am Engineer Mohammad Faisal Khan, Coordinator and Lecturer, Department of Technology. My course is Power Generation System, which is included in a program of BSc Electrical Engineering Technology, third semester. So today our second lecture, and the topics of our second lecture are sources of energy. So there are two types of sources of energy. One is conventional and the other one is the non-conventional source of energy, and the second topic will be efficiency. So first of all, the first topic is sources of energy. So the question arises that why we study the sources of energy in this power generation system course. So you know that electrical energy is produced from energy available in various forms of nature. So what is energy? Energy is actually another word for power, and it makes things move and machines work. It provides us with light, and we use it to heat and cool our houses, our offices, and to cook our food, and to transport people and goods, and etc. So these are all the applications of energy. So that's why the sources of energy is necessary to understand, and it is desirable to look into the various sources of energy. So there are actually two main sources of energy. One is the conventional source of energy, and the other one is the non-conventional source of energy. We are concerned with these two types because we produce electrical energy from the various sources of energy available in nature. So let us understand that what is the conventional source of energy. The conventional source of energy is also known as the non-renewable energy source, and when we cannot reuse a source of energy after using it once, so we call them conventional source. After using some source of energy and you are unable to reuse it, so this source is known as the conventional source of energy, and these sources of energy are in limited quantity except hydropower. Because hydropower, which is also known as water energy or the water, is available in abundance in nature, while the other sources of conventional sources or the other types of the conventional sources are found in limited quantities. For example, wood, flowing water, nuclear energy, and the most important is fossil fuels, which is also known as, for example, coal, petroleum, and natural gas. So these are all the examples of conventional sources of energy. So almost you know that when trees and plants decay, so they turn into the fossil fuels we use today, and these are coal and petroleum, natural gas, and others as well. And after I think about 80 to 85% of all the energy we consume today comes from the fossil fuels. So however, we do not have enough to last forever. People burn more and more fossil fuels, and eventually the supply will run out. So they also pollute our atmosphere and contribute to the global warming. So over the past decades, scientists have been looking for other sources of energy to replace these fossil fuels, and those other sources of energy are actually non-conventional sources of energy, which are also known as the renewable energy sources, which will be studied in next slides. And the major fossil fuel we use today is coal, petroleum, and natural gas, and these are called fossil fuels. But the two main problems of the non-renewable or the conventional sources of energy is this, that they are limited in quantity, and environment pollution. So combustion of fossil fuel emits large quantities of gases, which are, for example, carbon dioxide, which is a greenhouse gas. So this is probably the main reason of global temperature increase in the last years or last decade. So actually the conventional sources of energy are are decreasing day by day, and the non-conventional sources of energy are found in nature in abundance. So actually the scientists and the technical people, engineers, these are involved in research in how to utilize the non-conventional sources of energy, which are all which is also known as the renewable energy source. So the first we will study the wood. So what is wood? Wood is actually in ancient times, from very ancient times, the rural people, the people lives in villages and far away from the cities, use the fuel wood for their day-to-day cooking, which comes from natural forests and plantation. But the availability of the fuel wood has become difficult due to the rapid deforestation. We can avoid this problem by planting more trees on degraded forest land, cultivable wasteland, and barren land, and grazing land, etc. But wood is the conventional source of energy, which has been used for the heating purpose or for cooking purposes from the very ancient time. Number two is the flowing water, which is also known as the hydropower. So hydropower or water power is power derived from the energy of the falling or fast running water. So the water may fall, like you see in many जिसको आप आबशार भी कहते हैं, और if you construct a dam and you raise the level of water, अगर आप डैम बांधते हैं और आप पानी के लेवल को ऊपर लेके जाते हैं, so it stores some potential energy. Or and the other way is the fast running water. For example, if you have ever seen the Ghazi Brota project, so it has a certain slope, and that's the water runs in slope, which is a fast running water, which has a huge kinetic energy. So actually that energy, that speed, that fast running water or the falling water may be harnessed for useful purposes. So hydroelectricity is actually the application of hydropower to generate electricity. Hydroelectricity is a term in which we produce electricity from water. So this is actually the application of hydropower. It is the primary use of hydropower today. We all are aware that our country is also mainly dependent on the usage of hydropower, and we produce a huge amount of electrical energy from the hydropower. Hydropower plants can include a reservoir, which is generally created by a dam. If you create or construct a dam, so actually you are forming a reservoir. And that reservoir will be exploited the energy of falling water, or can use the kinetic energy of water as in runoff of the river hydroelectricity. Number three is coal. Coal is the most abundant conventional source of energy, which could last for at least 200 years. It is actually a black brown sedimentary rock. Formation of coal occurs when the remains of plants convert into lignite and then into anthracite. This involves a long process that takes place over a long period of time. Coal helps for various purposes, such as the heating of the house and the fuel for boilers and the steam engines, and for the generation of electricity by thermal power plants. So these are actually the applications of coal. But it has a major problem as that it creates pollution, and its emission, which is in the form of carbon dioxide, may affect the greenhouse effect, ozone layer, and it pollutes the atmosphere. As a result, it is injurious to health. The fourth one is the fossil fuel. With fossil fuel, actually coal is also a fossil fuel, but we have put petroleum and the natural gas as a fossil fuel. So petroleum is actually the mixture of carbon hydrocarbons like alkanes and cycloalkanes in crude form. You see that the black liquid is known as petroleum. In crude form it is known as the petroleum, and the formation of natural gas occurs when the gas comes in contact with the petroleum layer. So natural gas is a mixture of 50 to 90% of methane, ethane, propane, butane and hydrogen sulfide. After refining and purifying crude petroleum, it is available then as a petrol, diesel, lubricating oil and plastic, etc. Natural gas is also making a significant contribution to the household sector. We use natural gas in our houses for our cooking purposes and for heating our rooms, our houses. It causes less air pollution as compared to the other fossil fuels. If you compare these natural gas with the coal and other forms of conventional sources of energy, so it causes less air pollution. But it is very dangerous if explosion may occur if it is not used properly. The fifth one is the nuclear energy. So nuclear, as the name indicates, it is the energy of the nucleus of an atom. And next lectures, in next few lectures, we will study the atomic physics. I will give you a brief overview of the atomic physics, from where you will clear that what is the nuclear energy, how the nuclear energy is utilized, how it is converted to other forms of energy. So a small amount of radioactive substance can produce a lot of energy through the nuclear substances all over the world. It is estimated that the heat produced by 1 kg of nuclear fuel, it is important. It is important. I will read out this sentence again. It is estimated that the heat produced by 1 kg of nuclear fuel, which is uranium, is equal to that produced by 4,500 tons of coal. If you burn 4,500 tons of coal, 1 ton is equal to 1,000 kilograms. If you combust or if you utilize such a huge amount of coal, it gives you some amount of energy. But that output energy which we gain from burning 4,500 tons of coal can be achieved and by utilizing only 1 kg of nuclear fuel, which is uranium. If you utilize 1 kilogram of uranium, it gives you equal amount of energy which can be produced by 4,500 tons of coal. So actually nuclear power plant use uranium as a nuclear fuel in the reactor, and we will study it in detail in 5th or 6th week. So nuclear energy is one of the most environmentally friendly conventional sources of energy, as it produces fewer greenhouse gas emissions during the production of electricity in comparison to sources like coal power plant. As compared to the coal power plant, so nuclear power plant are environmentally friendly. Although in case of accidents, these are few exceptions. In few cases, when the accidents occur, the same nuclear energy releases in high amount is in the environment, and it is very dangerous. Although the nuclear waste that remains is radioactive and hazardous. It is hazardous, and that in case of accidents, it may pollute the atmosphere because it radiates or emits some radioactive substances. So nuclear energy is also an important form of conventional source of energy. Okay, the second one is now comes toward the non-conventional sources of energy, which are also known as the renewable sources of energy. So renewable energy flows actually involve natural phenomena such as sunlight and wind and tides and plant growth and geothermal heat. But actually these sources of energy are known as the renewable, and these sources are continuously replenished by the natural processes. Uh, these are naturally reloaded, and the renewable energy are also referred as the clean energy, comes from the natural sources or processes that are constantly replenished. For example, sunlight or wind keep shining and blowing, and even if their availability depends on time and weather. So this is the drawback that the weather plays a very vital role in providing the renewable energy. So for example, the wind energy is the form of non-conventional source of energy, the tidal energy, the solar energy, the geothermal, and the biomass energy. Because from many years we are using the wind energy and we convert the energy of wind into electrical energy through some arrangements which are known as the wind turbine. But these are actually the research oriented area, and it is estimated that I studied somewhere that by 2040, after 20 years since now, renewable energy is projected to equal coal and natural gas electricity generation, because I said that uh, about 85% of all the energy we consume today comes from conventional sources of energy, in which the fossil fuels plays a vital and major role. But it is impossible to last forever, because people are burning more and more fossil fuels, and eventually the supply will be run out. So the people now, the scientists and the governments are thinking to transform the new technologies, and they want to generate electricity, or they want to get energy from the renewable sources, which are wind, tidal, solar, which is sunlight, and geothermal, the energy of internal earth, and biomass, etc. So first, number one is wind energy. So wind energy is actually the harnessing of wind power to produce electricity. When you install a setup as in the figure, these are the wind turbines. So you are actually harnessing the wind power, and you are producing electricity from it. So wind turbine converts the kinetic energy of wind. The wind, these in turbine, if you see at the blades of the turbine, so the wind is flowing across the blade, so the blade will rotate in a certain circular motion. So it converts the kinetic energy of wind into mechanical energy, and after that there is some alternator or generator installed, which converts the mechanical energy into electrical energy. So we can harness wind energy very easily, but we have to install wind power plants or wind turbines. The second one is the tidal. So the tidal power or tidal energy is a form of hydropower. If you see in the figure, so the tides are created in the sea, and the tidal power, tidal energy is the form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. Seawater keeps on rising and falling, alternatively twice a day, under the influence of gravitational pull of moon and sun, which are called tides. There is actually a gravitational pull between the moon and the sun, due to which the tides are created in oceans, and we utilize those energy, the tidal energy, obtaining electricity. So although not yet widely used, it is not being widely used yet, but tidal energy has the potential for future electricity generation. In future electricity generation, tidal energy has the maximum potential. So tides are more predictable than the wind and sun. This is the advantage of tides, that tides are more predictable than wind, because the wind and the sun mainly depends on the weather, climate changes. If it's raining, so you are getting less sunlight. If there are The wind also depends on nature, that sometimes in few months they are breezing and blowing very fast and huge wind energy is available, but in few weeks or few months you are unable to get wind. So actually the tides are more predictable than the wind and the sun. Okay, the third one is the solar energy. This is the very important form of energy. Solar energy is the most readily available and free source of energy since ancient times. The sun is the primary source. I have highlighted this sentence. The sun is the primary source of energy. If you are being asked, if someone asks you that which one is the primary source of energy, so your answer must be the solar energy, the sun. The sun is actually the primary source of energy. So, and from very ancient times, we are utilizing the energy of sun, and the energy of sun is actually the responsible for creating trees and growing trees, and then those trees will form, we get wood from that tree and we will utilize. So the sun is actually the sun is responsible for making clouds, and those clouds with the help of wind energy flows and it rains. When it will rain, so it will again form a river, and you utilize that river according to your requirement. You construct a dam. So actually the sun is playing a very vital role in our world. So solar energy is radiant light. Actually, what is solar energy? It is the light and heat from the sun that is harnessed using a range of ever evolving technologies such as solar heating, photovoltaic, solar thermal energy, solar architecture, and artificial photosynthesis. These are actually the applications of solar energy. For your information, let me share that the Earth receives 174 petawatt of incoming solar radiation in the upper atmosphere. So 174 petawatt is a huge amount of power. 1 peta is equal to 10 raised to power 15. So approximately 30% is reflected back to space, while the rest is absorbed by clouds, oceans, and land masses. So it is a huge amount of energy if we install solar panels, and if we able to increase the efficiency of the solar panels, which is now almost 18%. So if we are able to convert maximum sunlight into electrical energy or other form of energy, so it will be a great achievement. So it is a research oriented area, and many people are using solar PV cells and solar cells and the solar panels to get electricity from that. The fourth one is the geothermal. So geothermal is actually the energy of Earth's interior. Hot springs are best example used since the ancient times. Treatment of muscular diseases, bathing. For muscular diseases in old times, so hot springs water were used to treat that muscular pains. Geothermal power is actually cost effective, reliable, sustainable, and environmentally friendly. These are the few advantages of geothermal power. That this is very cost effective, it is reliable, sustainable, and environmentally friendly. But actually the energy of the core of Earth or the Earth's interior is known as the geothermal energy. The fifth one is the biomass. So biomass is a plant or animal material used for energy production, electricity or heat, or in various industrial processes, or as raw substance for a range of products. All biomass is biologically produced matter based on carbon, hydrogen, and oxygen. So biomass is actually organic material that comes from plants and animals and includes crops, waste wood, and trees. When biomass is burned, so the chemical energy is released as heat and can generate electricity with the steam turbine. So this is all about the biomass, that when the plants and animals materials decay and the garbage the garbage or the remainings of crops or woods, these are all biomasses. So biomass is actually air pollutant. It is not environmentally friendly because if you burn these combust these biomass materials, so it will emit some dangerous gases which are hazardous. Now the second, I think you have understand what I delivered in my lecture. So actually, the renewable energy is often thought as of a new technology nowadays because it is some innovations are being made, and so it is thought as a new technology. Harnessing nature's power has long been used for heating, transportation, lighting, and more. Wind powered has powered boats to sail the seas and windmills to grain. The sun has provided warmth during the day and helped fires to light into the evening. But over the 500 years and so, humans increasingly turned to cheaper and dirty energy sources such as coal and fracked gas. So renewable energy are very important form of energy, and by 2040 it is it is expected that the renewable energy will be projected to equal to coal and natural gas electricity production and generation. So the second topic is efficiency. So efficiency in general terms, it has a very wide definition and wide spectrum, but we will study the efficiency, the electrical efficiency, the energy conversion, mechanical, and the other form of efficiency. So efficiency generally is the ratio of output energy to the input energy, and when you divide the output energy by input, you can also find the percentage efficiency by multiplying 100% into it, and one can say that this person is 40% efficient, and this power plant is 85% efficient, and this system is 60% efficient. So efficiency is actually the capability, the measurement of capability or performance of a system. So first off, the number one is electrical efficiency. So the efficiency of a system in electronics and electrical engineering is defined as a useful power output divided by the total electrical power consumed. This is electrical efficiency. And the energy conversion efficiency, which is very important to study, it is actually the ratio of useful output of an energy conversion machine and the input in energy terms. The input as well as the useful output may be chemical, electrical power, mechanical work, light, which may be radiation or heat. So this is the energy conversion efficiency. And the third one is the mechanical efficiency. It is the dimensionless number that measures the effectiveness of a machine and transforming the power input to the device to the power output. And the fourth one is the thermal efficiency. So in thermodynamics, the thermal efficiency is a dimensionless performance measure of a device that uses thermal energy such as internal combustion engine, a steam turbine, or a steam engine, a boiler, furnace, or refrigerator. So this was all about the efficiency. Thank you very much. But the efficiency is actually the ratio of output energy to the input energy. For example, if you have supplied some amount of energy to electric fan, so electric fan is actually rotating, so it gives you a cooling effect or some air. So actually you are converting the electrical into efficiency, mechanical. So the ratio of output to the input will be the efficiency. If there is a light bulb and you give an electrical energy as an input, so it gives you light, and beside light there is a slight heat as well. So actually you are converting one form of energy into another form. So in this aspect we will study the efficiencies of the major typical power plants, which will be studied in next lecture. So this was all about the efficiency. Thank you very much for watching, and if you have any questions, so put comments in the comment section. I will answer in next lecture. Thank you.